Hey guys, and welcome to the expressions review tutorial. I hope you have your expressions review out, ready to go over the answers and check your work. So let's get started. Okay, so real quick, we're going to go over the directions. It says to show work on all problems. Do not forget to check answers with the answer key on Google Classroom and to watch this video. So the first section we are going to do is part 1 is exponents. So in the directions for exponents, it wants us to write it in expanded form and also to solve for the answer. So we have to remember what this exponent means. Okay, so remember that this means I am multiplying the base 3 4 times. So it means I'm multiplying 3 times 3 times 3 times 3. Okay, which is not the same thing as adding. We are multiplying. Please remember that. This is not 3 plus 3 plus 3 plus 3. It's 3 times 3 times 3 times 3. So what we can do to solve this is we can solve each of them. 3 times 3 is 9. And this 3 times 3 is also 9. Put your multiplication sign down. And then 9 times 9 is 81. So that would be the answer for A, 3 to the 4th power. Question B is 10 to the power of 3. So this means I am multiplying 10 3 times. So 10 times 10 times 10. So we know that 10 times 10 is 100. Times another 10 is going to give me 1,000. Because we know when we multiply by 10, we're just moving a place value, or also known as adding a 0. So your answer for B should be 1,000. Okay, part C is 2 to the 5th power. So this means I am multiplying 2 5 times. So I have 2 times 2 times 2 times 2 times 2, and if you write this out on the exponent problems, you won't miss them. So once again, we're going to pair up. 2 times 2 is 4. Then I have another 2 times 2, which is also 4, and I'm going to drop this 2 down. Then I have 4 times 2, which is 16, and then drop the 2 down again, and 16 times 2 is 32. So your final answer will be 2 to the 5th power is equal to 32. Part 2, we are going to evaluate each of the following numerical expressions. So remember, the word evaluate means to find the value of. So when we're talking about numerical expressions, we have order of operations to help us solve these, which I recommend putting on the side of your paper. We have P for parentheses or B for brackets, just a grouping symbol. Then you have E for exponent, so that's like 5 squared. That's your exponent. Then you have multiplication and division, and these go left to right. And you also have adding and subtracting that also go left to right. So the first thing we would do in this problem, we would look to see, do I have any parentheses in this problem? We have no parentheses, so don't have to worry about parentheses. Then I go and do the same thing. Do I have any exponents? Yes, we have 2 separate exponents. So 11 to the 2nd power means 11 times 11, which is 121. And then I'm going to drop everything down. 7 times 6 minus, and we're actually going to go ahead and do this exponent as well because it's not being affected by the 11 squared. So 4 to the 3rd power means 4 times 4 times 4, which is 4 times 4 is 16, times another 4 is 64, divided by 2. Okay, some of you are not writing down your steps, and that's normally when we make our mistakes. Let's write down the steps each time. So now we are done with exponents, so now multiplying and dividing left to right. So the first thing that happens is the 7 times 6. So I'm going to leave the 121 alone, minus 7 times 6 is 42, minus 64 divided by 2. So I check again. Do I have any more multiplication division? I do. I have 64 divided by 2. Copying it down because I'm not doing anything with the problem. 64 divided by 2 is 32. So now I'm done with multiplying and dividing. So next we have adding and subtracting, left to right. So remember, this is the left side, this is the right side. So 121 minus 42 is going to give me 79 minus 32. And then 79 minus 32 is going to give me 47. And that's your final answer. Okay, once again, we have an order of operations, so I'm going to come over here and write my helpful reminders. So first, this time we do have parentheses, so we need to take care of everything in the parentheses, and we have 2 parentheses. So since they are both in parentheses, you can work on them at the same time. So when you start with parentheses, you have to start back over with the order of operations. So inside the parentheses, you would do the exponent 2 to the 3rd power, which is 2 times 2 times 2 first. And that gives me 8. But notice, I am still bringing the parentheses down because I have not done anything with the plus 13. Divided by, and then 12 minus 9 we know is 3. So then I have 8 plus 13, which is 21. Divided by 3, and that gives me 7. So 7 is your final answer. Okay, once again, it is a numerical expression. So I am going to write my order of operations. So we have several parentheses again. We have a parenthesis in a parenthesis. So you start with the innermost parentheses, and inside that there is an exponent. So that is the most important thing to start with. So we have 4 times 4, which we know is 16. So you're going to bring your parentheses down with this. So I didn't do anything with the 3 yet. This is now 16 plus 2 divided by 5. Okay, you drop everything down. Please don't do this in your head. So we still have an inner parenthesis. So 3 times 16 is 48. So now I have 48 plus 2 divided by 5. Then 48 plus 2 is 50. And then 50 divided by 5 is 10. And that's your final answer. Okay, we are on the last one of numerical expressions. Once again, writing my order of operations down to help me remember what to do. So don't have any parentheses. I do not have exponents. So we are starting with multiplication, division, and that goes left to right. So we are going to go through. This is the first thing we see, so we're going to take care of that first. So 13 plus 9 times 2 is 18 minus, and we can actually go ahead and do 14 divided by 2 is 7. And then we can do 13 plus 18, because adding and subtracting also go left to right, is 31 minus 7, and then 31 minus 7 is 24. Part C is prime factorization. So remember, a prime number is a number that can only be multiplied by 1 in itself. So examples of prime numbers are 2, 3, 5, 7, 11, 13. Okay, those are all prime numbers that you can use. Your answer can only have prime numbers in it. That's why it's called prime factorization. And factorizations are just numbers that you multiply to get a number. So let's get started. Okay, so there are 2 different ways you can work these, and I will show you both methods. So we have 120, and the way majority of the students work it is using a factor tree. We figure out what factors can multiply to make 120. Well, most of you, when I was walking around looking who has been working, did 2 and 60. 2 times 60 gives me the 120. And a tip that I gave my students is to circle your prime numbers. So 2 is prime, so I can stop on that side, but 60 is not prime. So I'm going to break 60 down. And then some of you chose 2 and 30. And 2 is prime again, so we circled it. 30, then some of you chose 5 and 6. You could have also done 3 and 10. And then 6 and 5 was actually prime, so we do need to circle it. And then 6 breaks down to 3 and 2. Okay, those are all prime numbers, so you have 2 times 2 times 2 times 3 times 5. But we are supposed to use exponents if necessary, and since I have repeated multiplication, That means it's an exponent, 2 to the third power times 3 times 5. And that would be the answer for this problem. Okay, 64. Once again, you can break 64 down into 8 and 8. And then you could break 8 is not prime, so you continue to break it down to 4 and 2. 2 is prime. And then break down the 4 to 2 and 2. And those are prime. And what's going to happen is you're going to do the exact same thing on the other side. And so you have all 2s. So you can think I have 1, 2, 3, 4, 5, 6 2s. So this is 2 to the 6. And if you decide to use the ladder method, so the way the ladder method works is you have to start with a prime number. Whatever number you put out here has to be prime. So I'm going to use 2 because it's an even number. So divide that by 2, I get 32. And I'm going to keep dividing by 2, and then I get 16. And then I divide by 2, and I get 8. Then I divide by 2 and get 4. Divide by 2, and I get 2. So then I have 1, 2, 3, 4, 5, 6. So that's the ladder method. If you do not like the tree method, you can use both. Okay, 180. So for your tree, you might have done 2 and 90. And then you could have broken 9. 2 is prime, so circle it. 9 and 10, neither of them are prime, so keep breaking them down. 3 and 3. Remember, these have to be factors, things you multiply. Okay, and then 10 can be broken down to 2 and 5. And so then we have 2 times 2 times 3 times 3 times 5, which can be simplified to 2 to the second power times 3 to the second power times 5. Okay, we are halfway through this video, so stick with it, you're almost done. Good job, guys. Okay, part D, we're going to write expressions for each of the following scenarios. So remember, an expression, an algebraic expression specifically, has to have a variable in it. And variables are the letters that we've been seeing in the math that we've been using lately. Okay, so the problem says a school club is ordering t-shirts. Each t-shirt costs $12. Write an algebraic expression to find the cost. And I really should have written the cost of any amount of t-shirts, okay, or to find the cost of t amount of t-shirts. So it says define your variable. So you could have chose any variable. You could have chose x. A lot of you were choosing the variable t, and that would be the number of t-shirts. If you chose t, that's how many t-shirts are you buying. So if it's each t-shirt, that means if I buy one t-shirt, it's $12. If I buy 2 t-shirts, it's $24. So you could think that this would be 12 times the number of t-shirts, so 12t. Another way you can help you write this is actually figure out, okay, if I buy 1 shirt, that'd be 1 times 12. If I buy 2 shirts, that's 2 times 12. If I buy 3 shirts, that's 3 times 12. Well, this is the thing that's varying, so that's your variable. That is t, and that's what the variable represents, that you can plug in any number and find out how much the cost of the shirt is. Okay, admissions to the high school football game is $3 per student. Okay, we've talked about those words before. Write an algebraic expression that represents the total amount of money collected. Let S represent the number of students, okay, who attended the football game. So they told us what variable to use. They want us to use S. So you have to think, well, if 1 student goes to the game, so let's think about that. If 1 student goes, I would do 1 times 3. If 2 students go, I would do 2 times 3. If 3 students go, I would do 3 times 3. If 4 students go, I would do 4 times 3. So this is my thing that's changing. It's the variable. So that means this would be S times 3, the number of students times 3. You can also write this as 3S, because remember, a variable and a number a variable with a coefficient means we are multiplying. This means 3 times S. Okay, letter C, Kylie bought several packages of bracelets. She wants to give them to 6 of her friends. That's important. She wants to make sure that they each give the same number of bracelets. Same number. Write an expression to describe the total number of bracelets Kylie will give each of her friend. Let B represent Kylie's total number of bracelets. So if you actually think about this visually, think of Kylie having like this big bag of bracelets. And we don't know how many she has. She could have 10, she could have 80, I don't know. So that's why it's represented as B, because we don't know how many bracelets Kylie has. Well, she's going to give them to 6 of her friends, but she wants to give them the same number. So if she wants to give them the same number, she would have to divide it equally. So this would be the bracelets divided by 6, and you can write it that way, or you could write B divided by 6. So the total number of bracelets divided by the 6 friends that she wants to give them to. Okay, part E, we are evaluating expressions. And once again, evaluating means to find the value of. So we're going to start with the tables. So in this, the n is your variable, and they are giving you what values they want you to plug in to the n in the expression. So first we have 2, so this would be 14. Well, I'm going to put 2 in now for n. 14 minus 2, that's 12. Then I would do the same thing for 5. 14 minus 5, because that's my variable is in, and it's the one subtracting, which would be 9. And then you have 14 minus 11, and you get 3. 14 minus 13, and you get 1. And 14 minus 14, and you get 0. Okay, on the next one, same thing. We have a variable. So we have to remember, though, when we see anything that says 2z, a number and a variable beside each other, this is equivalent to 2 times z. Those are equal expressions. So I'm actually gonna draw one more line so I can put my answer over there. So what I would do is say 9 plus, and I'm going to plug in 1 for z, 2 times 1. So I know order of operations, you multiply first. 2 times 1 is 2, plus the 9 is 11. So now we're going to plug the 3 in. 9 plus 2, and sometimes you'll see people put it in parentheses, which also means multiply. So 2 times 3 is 6, plus the 9 is 15. So then we have once again, we have 9 plus 2 times 7. And 2 times 7 is 14, plus the 9 is 23. And then the last one, we have 9 plus 2 times 2 and 2 tenths. And I know some of you are like, oh my goodness, there's a decimal. But guess what? You are rock stars, and you remember how to multiply with decimals. So let's just come over to the side here in our workspace. So 2 and 2 tenths times 2. Remember, we ignored the decimal at the beginning. 2 times 2 is 4. 2 times 2 is 4. And then we look, how many place values do I have? I have 1. So I need 1 in my answer. So I have 9 plus 4 and 4 tenths. So remember, just think about this as being 9.0 plus 4 and 4 tenths. That would give me 13 and 4 tenths. Okay, now we have just expressions, and it says, what if x equals 3? What would be the value of this 7x minus 9? So if x is 3, I'm going to plug in the 3 for this x right here. So we're just going to go plug that in. And remember, this means 7 times 3 minus 9. So 7 times 3 is 21 minus 9, and 21 minus 9 is 12. And that would be your final answer. Okay, next we have m to the 3rd power plus 18. They say, what if m is actually 2? So I'm going to take the 2 and plug it in for m. So I'm going to rewrite it as 2 to the 3rd power plus 18. And remember, 3rd power, this means 2 times 2 times 2, which would be 8. And 8 plus 18 is 26. Okay, part F, we are simplifying each algebraic expression. We're on the last section. Remember, simplifying does not necessarily mean you're going to have one value. It's just you combine all things that are alike until you get to where you can no longer combine terms. So in class, we talked about ways that we can identify like terms. They have to have the same variable and the same power. So if I'm looking at this first one, this 4y has a y, this 9y has a y, and this 8y has a y. And the 5 does not, so it is separate. So then if you did 4y plus 9y, that's 13y. So I have 13y plus 8y plus 5, and then 13 plus 8y gives me 21y plus 5. And this is your answer. You cannot combine variables with coefficients with no variables. Those are not the same thing. So today in class, we worked some problems out that had these parentheses. Remember we talked about the associative property where with addition, you can move the parentheses around because the order doesn't necessarily matter when we are just adding. Keyword there, just adding. So because we are just adding, we are going to move the parentheses to fit what really goes with this x. So if I'm looking what is a like term for x, it is 2x. So I'm going to rewrite this as x plus 2x plus 5 plus 8. Okay, and remember we talked about what variable is in front when I only have an x. Remember there's always this imaginary 1 there. It's 1x. So I have 1x plus 2x, which gives me 3x. And then these are just normal numbers. 5 plus 8 is 13. So this is your final answer. Okay, next, once again, we have parentheses. And so we cannot add 5x plus 4y, and we can't subtract 3x minus 3y because they don't have the same variables. So we are going to rewrite this so the variables that are the same are together. So I have 5x plus, so 5x and 3x are the same, plus 3x. And then we have 4y, and we also have minus 3y. Don't forget that subtraction sign. So we're going to do plus 4y because there's a plus sign in front of the 4y, but this is going to be minus 3y because there is a minus sign in front of it. So 5x plus 3x gives me 8x. 4y minus 3y gives me 1y, which is normally written as 8x plus y. Okay, next we have the distributive property. Remember we talked about that this really means that I have 4 groups of x plus 3. So this would be the same thing as saying I have x plus 3 plus x plus 3 plus x plus 3 plus x plus 3. I have 4 groups of them. That's what this 4 is telling me here. So, but we can also think of this as it is multiplication because when we are doing groups, that's multiplication. So we have 4 times x, which is 4x. And then we also have to multiply the 3 because it's also in the parentheses, plus 12. And let's check if that works. So here I have 1, 2, 3, 4 x's, and then I have 3, 6, 9, 12. So either way I work this problem, I get the same answer. Next, we have 2 parentheses 4x plus 3. So this is also the distributive property. So we are going to distribute the 2 by multiplying it to both numbers in the parentheses. So 2 times 4x is 8x, and 2 times 3 is 6. So my answer is 8x plus 6. Okay. Now we have another distributive property with with a variable on the side. So first, you still have to distribute. Remember, you only distribute to numbers that are the terms that are in the parentheses. So I would do 2 times 7x first, which gives me 14x, and then 2 times 8, which is 16. But see, there is a subtraction sign, so that's what we need to write down here as well. And then plus x. So then you have to determine, is this as simple as I can make it, or can I combine like terms? Well, this time we can combine like terms because 14x and x are like terms. So 14x plus x gives me 15x minus 16. And that is our final answer. Okay, we have made it to the last problem. I'm so proud of you. Okay, so this is a double distributed property. So we are going to do 3 times 5x first, which is 15x, and then 3 times 1, which is 3. Bring your plus sign down. Then we're going to distribute this 5. 5 times x is 5x. 5 times 6, which is 30. Okay, now I need to look, can I combine? Is there anything that's like 15x? 5x is. So I'm going to say 15x plus 5x plus 3 plus 30. So 15x plus 5x is 20x, plus 3 plus 30 is 33. I am so proud of you for watching the video and preparing for your test on Friday. Good luck. You'll do great if you've studied. Remember, take your time, double check your answers, and come into tutorials Friday morning so we can review.